Okie dokie. We're going to start our logarithms lessons with logarithmic properties. So these are basically the uses for logarithms, or some of them anyway, the types of logarithms, and then the rules that logarithms have to follow. So the first way that we want to look at logarithms is we would like to explore their connection to exponential functions. So for example, if I have y equals log base b of x, this is the same as the exponential equation b to the y exponent equals the value x. So every exponential function can be rewritten as a logarithmic function and vice versa. So I think that's pretty cool. And we do this for a reason. This helps us solve them a little bit better. So for example, if I have the function log base 3 of 9 is equal to x, when I'm looking at it like this, it looks completely foreign to me. Like I have no idea what to do with it. But if I rewrite it as its equivalent exponent, then I get 3 to the exponent x equals 9. And I know what exponent that's going to be, correct? 3 to the what equals 9? 2, right, because 3 squared equals 9. So by changing between these different forms, I'm actually able to solve these functions that otherwise would be really difficult to solve. So what we're going to start with is we're just going to practice changing them back and forth and then using that transition to solve them. So another example I would like to do is I would like to rewrite 2 to the x power equals 8 as a logarithm, and then I would like to solve it.
So we're solving for x, right?
Yes. So if I rewrite it, I get log base 2 of 8 equals x. We could use a calculator here, or, you know, we could just use our common sense. So if I multiply 2 by itself to get to 8, how many times do I have to multiply it?
3.
3. 2 cubed is 8. And we've got another one. So this one is 10 to the x equals 0.01. I would like for you to rewrite this as a logarithm, and then we will go ahead and solve it. If I rewrite it as a logarithm, we're going to get log base 10 of 0.01 equals x. We can go ahead and we can use our calculator to solve that. You're going to hit your log button. Each of our calculators already has a base 10 as a default. So I would just have to do log of 0.01, and you're going to tell me what answer you get. Hopefully everyone has a calculator with them right now.
-2.
You get -2, which means x equals -2.
I like this calculator.
Let's go ahead and do another one. Oh, goodness. So on this one, I have log base x of 32 equals 5. If I rewrite this as an exponent, I get x to the 5th power equals 32. That one's going to be a little bit difficult to solve unless I'm using a calculator, because I could just take the 5th root of both sides And I would get x equals 32 to the 1/5 power, and I can plug that into my calculator. And what do we get?
Is it 2?
We get 2, because 2/5 equals 32. Or 2 to the 5th power equals 32. We're going to do one more, and then we'll move on to the next piece. So the last one I would like for us to do is I want you to rewrite this one on your own and then solve it. So we have log base 10 of x equals 3. I would like for you to rewrite this as an exponential problem and then solve it.
Oh, snap.
So wait, exponential, would that be in the square root of it, or with it just being with the fraction as the exponent?
It would be written something like this. This is the exponential.
Oh, that thing.
Yeah. So we're in as some number to some power equals some number. So Jonah, how would I rewrite this one as an exponential?
X, no wait, 10, then x as the exponent equals 3.
You have that backwards. It's 10 to the 3rd power
Okay.
equals x. So then I can solve this, right?
Yep.
I just put it in my calculator. What's 10 cubed?
Isn't that 1,000? No, wait.
1,000, yeah. So by transitioning between exponential and logarithmic forms, it allows us to solve for different pieces. There are 2 different types of logarithms. The first one is our common log, which is what we have kind of been looking at. So this is a logarithm with base 10. And on our calculator, it looks like log, like it literally just is log. And this is the logarithm that we were just using in the exponential logarithmic conversion. The other type of logarithm then is called our natural log. And this is a logarithm that deals with powers of the constant e. And we represent natural log as L of n.
Wait,
So common log is, sorry, what'd you say, Han?
powers of E?
Yes, powers of e.
What is E?
I'll show you in a second.
Okay.
So common log we represent with log. Natural log we represent with ln. So what I mean when I say powers of e is just a number, but it's a constant. It's like 2.7 something. It's a base, though, that negates a base 10 that's happening, or a base e that's happening. So if I have a logarithm that is base e, and I'm taking it to e to the 2nd power, these e's are going to cancel each other out, and my answer is just going to be whatever that exponent was. So when I take a logarithm of base e to something, it's always going to cancel itself out. So it's a way of bringing an exponent down to our original level. We're not going to do a whole lot with canceling out using logarithms and e's, but it is good to know. And there are 2 different buttons on your calculator for these different logs. So log is our common log, ln is our natural log, and they're both on every calculator. So make sure you're paying attention to which log you are using and plugging numbers into.
All right.
So I mentioned that for common log, it always has a base 10, correct? Like I did say that. And on our calculators, most calculators only compute using a base 10 for a common log. But what if we're using a problem that doesn't use base 10? Well, there is a conversion we can do. This is called our change of base formula. And this change of base says, if I have a logarithm that has a base b that is not 10, I can still use my calculator to find its answer. In my calculator, I would do log of my large number divided by log of that base that I was using, and then it would give me whatever my answer is. So our change of base allows us to use a logarithm that is not base 10 and still plug it into our calculator. So of course we're going to do some examples just because it's super handy. The first example I would like to do is log base 3 of 15. This is not something that you can just plug directly into your calculator because the base here is 3 and not 10. And our calculators really only deal with log base 10. So I need to change it so that I am able to plug it into my calculator. In order to do that, I use this change of base formula, which says I'm going to take log of my large value divided by log of my base. And each of these I could just plug into my calculator. So I would do parentheses log 15 divided by parentheses log 3, and you should get your answer.
Parentheses divided by 2.46.
Correct. I want to make sure everybody's able to compute that. Okay. Kennedy, Jonah, Steven, how about you guys?
Yeah, I got it.
Okay. Steven, how about you? You don't have a calculator, do you? You're along for the ride.
I'm actually typing in one right now.
Oh, sweet.
Steven, you're such a goat.
And
Did
yeah,
you
I
get
got
it
the same
worked out,
thing.
Steven?
I got it.
Okay. So I'm going to have you do another one just as practice, and then we'll move on to the last portion of our notes. So this last one I would like you to do is log base 5 of 35. And I would like you to change that using our change of, or solve it using our change of base formula.
I messed up. Log. Uh, 2.2
Anybody else get 2.2?
or 2.21, yeah.
That sounds about right to me. Anybody have any major issues with that?
Nope.
So if we are presented with a logarithm that is not base 10 and we're still expected to solve it, we know that we can use our change of base to do so. If I give you the option for a cheat sheet, I highly suggest you put a change of base formula on there, okay? Because it is extremely helpful unless you can commit it to memory. So the last piece of our notes are actually the log rules. So we use these not only to solve logarithms, but we use them to expand them and condense them as well. So to rewrite them in different forms. The first log rule that I have is when I'm taking the log of two numbers that are multiplied together. So in this example, I have log base b of the function m times n. If I were expanding this, it would be rewritten as the addition of both of those logs in base b. So multiplication expands into addition, which means addition condenses into multiplication, so it does go both ways. We have a similar one when a division happens inside of a logarithm, except this one expands into subtraction. So log base b of m divided by n is the same as log base b of m minus log base b of n. So we always do numerator minus denominator.
Makes sense.
And then the last rule that we have says that if I have log base b of some number or function to an exponent, I can just bring that exponent out front and multiply it into the logarithm base b of that function. And that again also goes both ways. So if I if I have a constant in front of my logarithm, I can rewrite it as an exponent on whatever I'm taking the log of. So these three rules allow us to expand them, which makes them bigger, or condense them, which makes them smaller. But ultimately, they let us rewrite these in a way that makes it easier to solve. So what we're going to do next is I have two examples. We are going to use those examples then to simplify them. One of them is going to be expanding, and one of them is going to be condensing. So expanding means to make it bigger. Condensing means to make it smaller. Okay, just so you know. I figured you guys know that, but sometimes it's forgotten. So the first example I would like to do is I would like to expand this logarithm. So I have log base 4 of the square root of 128. Not only am I going to expand it though, but I'm going to expand it and then solve it, just for fun. The first thing I'm going to do is I'm going to get rid of that square root because I really, really don't like it. I can't cancel it out though, which means I just need to rewrite it. When I take the square root of something, that is the same as raising that value to the 1/2 power. So that is the same as log base 4 of 128 raised to the 1/2 power. I have a rule though that says if I have an exponent on whatever I'm taking the log of, I can bring that exponent out front and multiply it into the entire logarithm. So then this is the same as 1/2 times log base 4 of 128. Everyone okay with what I did there?
Yeah.
128 is a pretty big number. So what I would like to do is I would actually like to break that up into two smaller numbers that multiply together to get 128. So the ones that I came up with were 64 and 2. So then this is the same as 1/2 times log base 4 of 64 times 2 I have a property that says when I'm multiplying two things together and I want to expand it, I can rewrite it as addition, both of them with log base 4. So then this is the same as 1/2 times, and I'm going to go ahead and use a big parentheses here. Log base 4 of my first number plus log base 4 of my second number. From here, the easiest way to simplify this is going to be to do a change of base formula on each of these logarithms. So I would like you to do log 4, 64 and use the change of base to tell me what it is. Right, we remember how to do that? So you're gonna do log 64 divided by log of 4. What do we get? Yes, Devin, that is correct. Let's see what everybody else gets.
So I got 3.
You should get 3 because 4 cubed equals 64. I would like to do the same thing with log base 4 of 2. Do your change of base to tell me what it equals. So change of base, we do log of our larger number divided by log of our base. So log 2 over log 4.
0.5.
1/2, yep. Give everyone a chance to catch up. In order to finish solving this, I need to put together the 3 and the 1/2. I like to do it as a fraction. So this is the same as 6 halves plus 1/2, which is 7 halves. And then I just go ahead and multiply them together to get 7/4, which is 1.75. So that means that log base 4 of the square root of 128 equals 1.75. I would not expect you to do all of this excessive work on a test or a quiz, but it's nice to see how the properties play into it. You absolutely could have gotten right here and then just use your change of base formula to do log 128 divided by log 4 and then multiply your answer by 1/2, and it still would have worked out the same way. Okay? So I would not expect you to expand it this far on your homework. I mean, not on your homework, on a test or a quiz, but it's good to know how the properties play into it. Okay? Anybody super confused by anything we did here? Okay, we're gonna go ahead and do one more. And on this next one, I'm actually going to condense it. So my goal is to make it smaller using those log rules that we talked about. So this example is 3 log of x plus 2 log of the quantity x minus 5 minus log of x. When I'm doing anything with logarithms, I like to move left to right. And I like to start with the third rule that we learned, which is the exponent rule. Okay? So it says if I have an exponent on whatever I'm taking the log of, that exponent value can be multiplied out front in front of the log, which means any number written in front of my log was originally an exponent. So this 3 was originally an exponent on the x, and this 2 was originally an exponent on the x minus 5. So I'm going to rewrite it, putting those exponents back. So then this is the same as log of x cubed plus log of x minus 5 squared minus log of x I've done the exponent rule, so now I need to look at my other 2 rules. Moving left to right, I have addition happening. So what rule deals with addition?
First one.
The first one, which says, if I have 2 functions inside of a logarithm being multiplied together, it can be rewritten as addition, which means any addition can be rewritten as multiplication, right? So I'm going to take these 2, and I'm going to rewrite it as the multiplication of x cubed and x minus 5 squared. So then this becomes log of x cubed minus x minus 5 squared, and then still minus log of x, because I haven't done anything with that yet. I know that I can put all of these together because they all have the same base. Since there is no number, like little number after each of the logs, we assume it's all base 10. So I condensed this part, but what do I know about this subtraction happening right there? Chandler cannot answer.
Isn't it like division or something?
Right, it corresponds to originally having divided two functions within a logarithm. These are both base 10, so I can rewrite it as a division problem, where this is my numerator and this is my denominator. So then this becomes log of x cubed minus x minus 5 squared, all in my numerator, over the x in my denominator, and then I'm done. So we used those log rules that we had to condense this extremely long logarithmic problem into one log. They still mean the same thing and they will still solve to the same thing. We just rewrote it in a different way. Does that kind of make sense?
Yeah.
Anybody not have it make sense at all to them? Kennedy, is that no that it doesn't make sense or no it does make sense? Okay, just checking. Jonah, how about you, hon?
I think it makes sense.
Okay, Stephen, what about you?
Everything makes sense. I'm just curious what log does to the number.
What log does to a number?
Yeah.
We will explore that when we get to our next couple lessons. We are going to do logarithms for about the next 2 to 3 days because it's kind of a long process. So what I'm going to do now is I'm going to let you, I don't know, go do something productive. If you're missing any work for my class, I expect that you're going to work on that. If you do not, then you can work on anything that you need to. If you have any questions, of course, I will stay in this Google call until the end of class. Also, I will be moving these Google Meets to the Google Classroom platform. It'll probably start next week, so it shouldn't impact most of you. However, if anybody was virtual before and intends to stay virtual, we're still going to do live class meetings, but it will be through Google Classroom. And the links will be posted on Canvas still, but it just won't go. It's not really changing a whole lot. I just have to go through Google Classroom now. You're free to go.
All right. I sent you the email.
Okay, perfect.
All right. Take
Thank
care,
you.
Mr.
Thanks, you too.
Bye, Carol.